Hi, thank you all for being here and being on time. Um, as usual, well, I'll start at about 11:05, give people a chance to show up. So just sit tight and let me know. Are there any quick questions anybody has while we're waiting?
This is not computer science related, but
Yeah.
I heard a rumor that our we would be graded by the grading policy of our college in our non-art college classes, and I'm wondering if you have any idea if it's true because the registrar hasn't responded to me yet.
It's very confusing. I actually don't really know the answer. I initially we were told that professors could set their own grading policies within their own classes. Um, I think what's going to happen, and I'm not totally sure of this, is at the end of the semester, there'll be a drop down menu, and I'll be able to select a grade for each of you. And I think what's going to happen is all the letter grades will be there as well as some version of pass and fail. So the professor can just pick whichever they want for each student. Um, and I say some version of pass and fail because Pitzer's now calling it like COVID credit slash no record COVID or something like that. I don't even know what the code is. So the drop down menu will contain different options for each student depending on their college. But I think there'll be an option for pass fail and for letter grades for each student.
Okay.
I know for Pitzer, the default option has changed to pass fail for every student, but students still technically can opt into letter grades, but I think it's still up to the professor to approve that. So even if a student wants a letter grade, the professor can say no letter grades for anybody. Um, right. So the script register says we're graded by our own college's grading policy. Yeah, I think what that means is that that the drop down menu contains options that are determined by each college. I think that's what that means. I'm still not totally sure. So I need to clarify this for myself. Um, and I'm still also thinking about what to do. Some students have come forward to me um, with some pretty compelling cases why they would like a letter grade. I'm still very hesitant to grant letter grades for anybody. Um, the students have asked for, instead of pass fail, for everybody to get an A or fail. And so it doesn't affect your GPA. And I'm actually amenable to that. Um, I'm not amenable to everybody just automatically getting an A no matter what. And then, A or fail seems really extreme to me. So I don't know what the right compromise is, to be honest. I'm still thinking about it. Right now, I had said to this class was that I was going to move everybody to pass fail except for really compelling cases, and I'm going to stick to that for a while, but I'm still thinking about it. Anybody have any thoughts on that they want to share before we start class? Any personal feelings about this, about what the right compromise is? Nobody? Okay. I'd love to hear what you all think because I'm still, I keep going back and forth myself. All right, let's see. Only a couple more people are showing up. So let's just get started. It always takes me a while to get my iPad set up. So give me a minute here. Max says, I personally have just heard that the grad schools aren't being as forgiving as people were hoping by accepting pass fail. Totally anecdotal though. Yeah, we've talked to a few grad schools and they've said they have, but we haven't sampled every grad school in the country. So yeah, it's very anecdotal. It's very hard to say what's going to happen. I would hope that everyone's realizing this is a weird semester, so transcripts might look weird, but I guess that is just a hope. All right, let's see. I'm trying to share my screen. I've been having problems with this recently. It always, for some reason, it just takes either just takes time or there's something I always have to do. Try that again. Share. You all are not seeing anything still. I never understand what I have to do here. No, I'll get this figured out in a minute. Let's try this. Still nothing. Oh, here we go. I don't know why it takes so long. Nope, and you're still not seeing it. Oh, there we go. Finally. All right. Oh. Yes. Okay, finally. All right, let's get started today. I've used the term object-oriented programming language before, and today we're actually going to learn what that means. Python is an object-oriented programming language. Oh, and I spent all that time trying to share my iPad screen and realized I actually want to start with the code window. Let me pull up Visual Studio Code, and let's just look at some things. That you may already know, but I want to emphasize. Terminal. All right, let me share. Okay, you all see my code window? I think you are.
I can see it.
Yeah, good, thank you. All right, some things that you all know. For instance, let's say I say x equals 7, right? Then I could ask for the type of x. Okay, it's an integer. All right, that type there is something called a class. It's saying that 7 is in the integer class. Classes have certain operations and they have data. So within the integer class, you can do division. You can do addition. Right? Let's say y equals 8. There's another integer type y. Okay, and I could do x plus y, and that makes sense, right? So we know we can add two integers. But if I try to do x divided by y, I get an answer, but it's an answer of a different type. Not an integer anymore. It's now a floating point number. Integers have certain built-in operations, and other programming languages, if you divide an integer by an integer, then it'll give you an error because you won't get another integer, and you can only stay in the same class, right? So the class here is integer. If we want to see what all of the things in the integer class here, this should work. These are all of the operations we're allowed to do with integers. Now, the second one on this list you see is add, but it's got 2 underscores. So you don't type the word add if you want to do addition, you use the plus sign. And the 2 underscores mean that that's an operation that is allowed among the world of integers, but the 2 underscores mean there's a special symbol for it. Don't use the word add, use addition, okay? Now we'll see with other classes, like down here at the very bottom, it says denominator or from bytes or numerator and or real. These are all things that don't use, um, let's see, so let's try this. Let's do 8.real. See if that works. No, 8.real. That gave me an error. Well, let's see what it is that I'm trying to get at here with objects and classes. So let me go back to my iPad screen and we'll talk about this in more generality. I just wanted to point out that you've already seen classes. And in fact, in Python, everything is an object. So the way you should, the analogy here is that a class is a type, right? Integer is a type, floating point's a type, and an object is one thing of that type. So the number 8 is an integer. The integer int is the class. 8 is the object, right? So the word down there at the bottom of the screen is instance. 8 is an instance of the integer class. Now, you can make your own classes and objects and add functionality to those classes and objects. So you got to understand, though, what a class is and all of the elements of a class. So classes have really two aspects to them. They have their functions, which are also called their methods, and they have their data. So, for example, the number 8 is in the int class, right? So 8 is an object in the int class. 8 is the data, but 8 also has some functionalities. For example, you can add 8 to 7. So addition is one of the functions. It's one of the methods associated with the int class. Division is not a method associated with the int class because when you divide two things, you don't get an integer. We're going to see how that works by creating our own class. So classes, again, every object of a certain class has two aspects to it. There's the data aspect, what data is stored, and there are the functions that you're allowed to do with that data. So we're going to look at a definition of a student class. So again, the analogy here is student is going to be the class, right? So student is going to function like int. And a particular student, one of you in the class, is an object, right? So a particular student is an object, and student in general is the class. The data is contained for each object. The associated data will be that student and their graduation year, right? Name, year. Now, there's a couple of functions that we want to define for each student. So for example, if a student decides to defer their graduation, they want to take a leave of absence for 2 years, or they're an incoming student and they want to do a gap year after high school, that'll change their year of graduation. So we want to add that functionality to each student where we're allowed to say how much they're going to defer for some period of time, right? Maybe 2 years, 3 years. And what that changes, if you defer, is that'll change your year, right? So the defer function will change the data contained in that particular student's object, right? So each particular student is an object. They have a name and a year. The defer function is a function that'll work on student objects. And what the defer function will do is change their graduation year. Right? Now that's like an optional function that we're going to define. We're going to define the defer function. There are a couple of required functions. Every class has certain required functions. Init and Reaper are two of the required functions that you'll need. Init in particular, Reaper is optional, but almost every class has a Reaper function. Init is not optional. Every class has to have an init function. So here's what it looks like. Here's a one-page example of a class. So again, we're defining the student class here. We're not defining a particular student. The particular students are here at the very bottom of the screen. Okay, those are particular students. FR will represent a particular student. SR represents um, a different student, okay? And those are instances of this student class, right? So this student class is what's at the top. So the way you define your own class is with the class keyword. Should probably change colors here. The class keyword. Okay, that's what you use to define your own class. You have to give that class a name. This is the student class. Okay? Just like somebody who created Python created the int class. Right? And that defines this class where the objects are numbers and the methods are the name for functions, are things like addition and subtraction. Okay. There's two special functions here. There's the init function and there's the reaper function. Okay, so now what the init function does is it just creates that object. Init stands for initialize. Sometimes this is called in other languages, it's called the constructor. What this does is actually the init function is the thing that gets called, the function that gets called to actually create a particular student. Right? There's a lot of aspects here. There's going to be a lot of things to get used to here. Right? So we've got the words class, object, method, instance, right? There's a lot of terminology thrown around. I'm just going to be consistently using this terminology for the next hour, and I'm hoping you catch on. One of the other terms to know is the word self. So if I'm defining a class, if I'm defining a class, then I want to be able to do things with the data contained in that class. The way I refer to that data within the class definition itself is with the word self, right? So what self means is, it means, let's say we're working with a particular student, okay? That student's name is self.name, okay? And this is saying is that when I define a student, I'm going to give two arguments, the name argument and the year argument. And that student will have a name called self.name, which will be whatever the name argument is. So we're saying the self.name variable is whatever the name argument is that has been entered. You'll get the hang of this as we go through it. Okay, I know this sounds really confusing. I know it because I remember being completely confused the first time I saw it. But I promise you we'll get the hang of it. Self.year, that's the other data that's going to be associated with any particular student. Right? So think of the word self as a placeholder for a particular student. And we're saying self.year is that particular student's year. And the way we set self.year equal to some number is by putting that number in parentheses, and then that number will go here. Okay, so self.year will be set to be whatever number has been input to create that student. So if you look at the very bottom of the screen down there, we're creating this student FR, right? Their name will be Frosh A. So if I now type FR, if I type FR.name and I hit enter, what I'll see is Frosh A. And if I hit FR.year and I hit enter, what I'll see is 2022. The second student there at the bottom of the screen, their name is SR, right? SR is going to refer to that particular student. If I type SR.name, I'll get senior B, and SR.year, I'll get 2019, okay? These are called the attributes of the student. So whenever you see self.something, and that represents a piece of data, those somethings, name and year in this case, are called the attributes of that particular class. Again, a lot of terminology here we're throwing around, right? So we're defining the student class. Each particular student will have two attributes. Those attributes will be their name and their year, and that name and that year are going to be set by the init function, which takes two arguments at top, which are right over here, name and year. And we'll define our own. And I think you see, as we define our own, this will make a lot more sense, right? So that's the init function. All the init function does is it creates a particular student. Now, let's say we've created the student, and now we want to, and now we've created a particular student. So at the bottom of the screen, we created the student FR. So now we want to know, well, I forgot what FR is. What is FR? Well, we could ask, what is fr.name? We could ask, what is fr.year? Or we could just type fr, and Python should print something back to us with all the data, and we can format that however we want. So that's what the Reaper function does. REPR really stands for representation. This is how we're going to represent to the world a particular student. What we're going to do is we're going to report on their name as a string, because it gets input as a string. And then we're going to add to that the string which represents their year. And when we return that, that's what gets printed to the screen. So if I just hit FR or print FR, what I'll see is their name and their year, because that's what the representation function tells me to print to the screen. Okay? So the init function and the Reaper function, those are special functions, which is why you see these underscores before and after. Okay? Defer is not a special function. Defer doesn't have any particular meaning to Python. Defer is something we're going to define, just another function of our own design. And the way the defer function works is, well, it's going to take a particular student. And again, within the class definition, the way I refer to a particular student is with the keyword self. Right? So the defer function takes a particular student, and it takes some number of years to defer. So that's num years. Okay? And the way it's going to work is it's going to take the year associated with that student, right? The year attribute of that particular student, and it's going to add num years to that. So it's going to change the year attribute of that student by num years. Let's go ahead and do this. I'm going to just type this in real quick. I don't think it'll take long to type it in. Well, we'll see other examples. Let's move forward, and then maybe we could come back and create examples ourselves. Would take a little while to type it in. Here's some other types that we've seen. The string type, okay, but type is just another word for its class. So if I type s equals string 42, str is the constructor. Str is the init function. Okay? The init function right here is called str for the string class. If I ask for its type, it's going to give me the name of the class, which is a string. And if I type dir of that, it shows me all of the methods or functions that work with strings. So for example, capitalize is a function that was custom designed to work with strings. Each object is a container. So in other words, thinking back to the last lecture, if you refer to a list, then really you're referring to a memory location. Okay? So if I refer to an object, I'm referring to a memory location where that object is stored. And there's lots of stuff stored there. There's all its data and its functionality or methods. So an object contains its own function. In other words, you should think that the number 7 somehow is a container that actually contains a lot more than just the number 7. So the number 7 also contains all of the functionality associated with 7. So the addition function, the subtraction function, those are all the methods that work with the number 7. So if I type dir of 7, what I'll get is all of the methods contained in the 7 object. Okay? Again, in the definition of a class, if I want to refer to the object that's been defined, I use the word self. So that's just within the class definition. If I want to refer to this object, someone else is going to come along and create that. There's that keyword self. And then there's these 2 special methods, which have, and since they're special, they get underscores before and after them. There's the init method, which is called the constructor. That's the actual function that creates new objects of that particular class. And then there's the reaper function, which tells Python how to print that particular object. Let's look at another example. This one's a little bit more involved. And I think as we look at more and more complex objects, you'll get a better feel for what all this terminology means. Okay, so this is a nice example because we'll have lots of good methods here. We're going to define a date class. The date class is going to have 3 attributes. So each date object, right, so D is a date object. Date will be the class. D will be an object of that class, right? Just like int is a class and 7 is an object in that class, right? So date will be the class. Little d will represent a particular object of that class. That object is going to have 3 pieces of data that we're going to store. So those will be the attributes. There'll be the month attribute of D, the day attribute of D, and the year attribute of D. Right? And then that whole object is going to get stored at a particular memory location. So here's how we're going to define it. This would be the quiz for today, but we can just go through it kind of slowly. So there's a couple things to see here. There are things on here that we haven't seen before, but I'll just kind of talk through those. So again, the way this has been defined right now is it has the 2 required methods, the init method and the reaper method, and then 1 kind of optional method. And then at the bottom of the screen, you see how to create a particular object in this class. So D will be a particular object. It will be in the date class, so we use the term date. And I'm looking at the bottom of the screen here. D is a particular object. It's in the date class. And when I create this object, little d, I have to give it 3 numbers, 11, 12, and 2013. And now Python is going to create a date object using those 3 numbers. And the way it's going to create that date object is by calling the init function. The init function takes those 3 numbers and puts them here, here, and here. There'll be MO, DY, and YR. Right? So in the lines following this, MO will represent the number 11, DY will represent the number 12, YR will represent the number 2013. Okay? Now, in the next line, we define the attributes of D. Right? So I'm thinking about what happens at the very bottom as we call this line here. So we execute this line at the bottom of the screen, right? Then MO becomes 11, DY becomes 12, and YR becomes 2013. And self becomes little d. So self becomes d. So it's saying d.month is going to be MO, which was 11. And d.day will become 12. And d.year will become 2013. Hope that's clear. Maybe that's a little bit clear, right? So self is a placeholder for the particular object you are going to create. And in this case, that particular object is called little d, right? And then MO, DY, and YR are the 3 numbers that have been input when you create that object. and then the init function sets the attributes of that function. So we're going to set the month attribute of D, the day attribute of D, and the year attribute of D by saying D dot month equals 11. Now I've set the month attribute of D to be 11. Now, if after that somebody just goes to the command line and just types D and hits enter, then something should get printed that contains all of the data that we just entered. And the way it's going to get printed is with the Reaper function. I don't want you to actually worry about this too much. This is just some special code to print that information out to the screen in a particular format. And it'll print it as 11/12/2013. So don't worry so much about that code right there. It's just some special characters that tell Python how to print stuff. We haven't talked about the dot format function. The custom function that was defined is the isLeapYear function. So this is just supposed to be a Boolean function, which we'll talk about more later in the class, which, when I say a Boolean function, I'm going to say, well, all I mean is this is a function that just returns true or false. Okay, so if I put D here where self is, and I call isLeapYear, I say isLeapYear D, or another way to do that is I say D dot isLeapYear and just put open and close parentheses. That dot notation, we've seen before in this class many, many times, but now we're really going to learn what that dot notation is. Whenever you have an object and then a dot, you can put after that object an attribute, so in this case, month, day, or year, or you could put after that dot a method, which is a function that will act on that object, right? So D dot isLeapYear is calling the isLeapYear function on the object D. I have to have open and close parentheses there because it's a function, but there's no other arguments to that function besides D, and we already know we're working with D because I said D dot isLeapYear. Right? So if you have a function that only calls self, if I have a function that only calls self, then when you call that function with the dot notation, you don't need anything in the parentheses because we already have the function here. We already have the object there. Right. Now, the way this is going to work, we'll talk more about it later, but all this is a bunch of if-then statements just to test if that particular object is a leap year or not. Okay, so we're going to just look at the year attribute of that particular date and then do some tests to decide if it's a leap year or not. And at the end, there's just a return statement that returns false or returns true, depending on if it's a leap year or not. The bottom of the screen there, the very bottom, you see a couple of different creations of a date, right? If I say D equals date 11/12/2013, now D is a date object whose month, day, and year attributes are 11/12 and 2013. Okay, I can say NY equals a date object 1/1/2019. NY, of course, stands for New Year. So New Year is January 1st of 2019 was New Year of last year. So I can create that date object, or I can create New Century. NC is another date object, 1/1/2100. So NC dot month would be 1, NC dot day will be 1, and NC dot year will be 2100. Okay, please, I should have the chat window up. Sorry, I don't have my chat window up, so I don't know if you guys have been chatting to me, but if you do have questions, and I don't see the chat window, there it is. Now I've really screwed things up. If you do have questions, just stop me and yell them out or put them in the chat window. And if I'm not looking at the chat window, it's probably better to just yell them out. Again, it's like a big giant mess. Like, what are each of these things? But the class keyword that defines the class is way up here at the top. The init function and the Reaper function are these two special functions. The isYear function is Oh shoot, I gotta pause this for a sec. I'll be right back. I'll be back in 1 minute. Apologize. Sorry. Sorry about that. Somebody was knocking at the door. All right. All right, let's move on. We'll look at some other attributes, some other methods. No other attributes. The attributes of the date function are just going to be month, day, and year. But we can define other methods. There's other things you might want to do to year. And that's what we're going to look at today. And that's what you'll do in your homework assignment. So in your homework assignment, you're going to play with this date class. You're going to define the date class yourself. And then you're going to add methods to that date class and then play with it, do stuff with that date class. And that should give you a good feel for what it is that you're going to create. Looking ahead, just to tell you where we're going, in the next class, we'll talk about creating a Connect 4 class. And the Connect 4 class will have certain methods like player 1 goes in column 2, and player 1 drops a checker in column 2. Or player 2 goes in column 3, right? Those are going to be methods in the Connect 4 class. And the Connect 4 class will be have attributes like the Connect 4 board. If you type Connect 4.board, then you'll see the current state of the game, right? So that'll be a more complicated example that we're working up to. The homework you had due today was kind of a warm-up for that. The functions you defined for today's homework, like the 3 in a row function, will become methods in the Connect 4 class. Okay, we'll take it slow. Hopefully, you'll get a feel for it. Right. Let's take a look at this screen here. Just to go into a little more detail about the is leap year function. So if you just look at Wikipedia or anything, you can see the pattern of leap year. So leap years, this is not something you need to know for this class, but you may be interested. Hopefully you all probably know there's a leap year every 4 years, unless it's divisible by 100. Then there's no leap year unless it's divisible by 400, in which case there is a leap year. So actually the year 2000 was special because that was a leap year, even though it was divisible by 100, so it shouldn't have been a leap year. Right? It's kind of weird. And so that's all this is leap year function is doing. It's just doing those Boolean checks. Is it divisible by 400? If it is, then it's a leap year, so hit true. If it's not, you go out to the next line and say, is it divisible by 100? And if it is divisible by 100, but you've gotten to this line, it means you weren't divisible by 400. So then you return false. If you're neither divisible by 400 nor 100, then you go to that third line and check are you divisible by 4. Right? If you're not a multiple of 400, you're not a multiple by 100, but you are a multiple of 4, then you're a leap year, so you return true. And then in every other case, all the cases we didn't talk about, you return false. Right, so the way you call this function is at the bottom of the screen there. Get rid of that. You say, so WD is, I don't know what that stands for. WD is some particular date. The attributes of that date are going to be WD.month. If I were to just type that, I'd see 11. WD.day would be 12. WD.year would be 2013. Those are the attributes of WD. And then to call the is leap year method, I could use that dot notation. I could type WD dot is leap year and then open and close parentheses because it's a function. Okay, and the output would be false because that function is only looking at the year 2013, and 2013 was not a leap year. Just like in the second example there, we can say little d is the date 1/1/2020, and that was a leap year. So if you call the is leap year method, then it will return true. Okay. Hope you're getting a hang of this language, right? We've got methods or the functions. Objects are the particular instances of a class. Attributes are the data associated with each object, right? I'm just going to keep using this language, try to get you all used to it. Not like learning a foreign language. You walk into a foreign language class and they just start talking in that language. And at first you have no idea what they're saying. And by the end of it, hopefully you start to pick up the language, right? So that's how we're going to treat this. A couple of other functions that we are going to define, that you're going to define in your homework. In homework 10, you're going to define your own methods for the date class. So we're going to expand the date class by adding functionality to it, which means defining new methods, right? So one thing you're going to define, and we'll talk about that today, is the yesterday method. The yesterday method takes a particular day, a particular date, and subtracts 1 from the day, right? So if I have a date and I subtract 1, well, normally that's easy. All you do is subtract 1 from the day, unless it's the first day of the month. And if it's the first day of the month, you have to think about decreasing the month number. So you have to really think about that too. We'll talk about that in a minute. And then you have to think, oh, well, what if it's actually the new year? What if it's the first day of the year? Then not only do you decrease the month, but you also have to decrease the year, right? So if I give you a particular date and you want a function that gives you yesterday's date, it's a little bit complicated. Same thing with tomorrow. If it's the last day of the month, then the tomorrow function gets a little complicated. And if it's the last day of the year, it's even more complicated. So your tomorrow, your yesterday function, your tomorrow function have to both take those cases into consideration. Once you've defined the tomorrow function, if you use that tomorrow function 5 times, then that's how you define the add n days function. So the add n days function just calls the tomorrow function n times. So you can advance forward. And once I've defined, I've advanced forward 1 day, I can define a new function that advances forward n days, or subtract n days by using the yesterday function. Another thing that we might want to define is looking at how to compare 2 dates. So if I have a date and another date, I can ask, is one date before or after the other date? So that's the is before and is after one. I can ask for how many days are there between those 2 dates? That's the diff function. And then that last one is the most interesting function. The DOW function stands for day of week. All that function is going to take is a particular date, and it's going to return the day of the week. Was that a Sunday? Was that a Monday? Was that a Tuesday? That's actually a shockingly complicated algorithm. Well, we'll talk about it today, and you'll know how to program it. But it's really hard to do in your head. It's not too hard for a computer to implement. And for those of you who don't know, Art Benjamin is in the math department at Harvey Mudd College, and he's a self-proclaimed mathematician, and he does all this mental arithmetic magic tricks, and they're actually amazing. So I encourage you all to look at Art Benjamin's TED Talk he did several years ago, and you'll see he does this thing. He'll just call up a random audience member and ask them what day they were born, and then instantly he tells them the day of the week, and that's a hard algorithm to implement in your head. And he's written a book on this, how he does it, and you can actually master that technique yourself. It takes a lot of practice. John Conway, who I mentioned last time, your homework was based on some of John Conway's work, is the other person also known to be able to do this in his head. Both Art Benjamin and John Conway, one of the things the two of them are known for is having mastered this sort of mental trick of being able to know the day of the week that you were born. And apparently they use different algorithms to do it. I know the two of them have talked about it. And the first time I met John Conway, and when I left him, he immediately said, what day were you born? And I told him, and he went, oh, that was Friday, bye. And then he walked away. It's very strange, because I didn't know he knew how to do that trick. Anyway, my own memories of John Conway. The diff operator, let's talk about that. So the diff operator, the way it's supposed to work, sorry, diff method, I should be using the right terms. The diff method is going to be a method associated with the date class. So here at the top of the screen, what we're seeing is someone comes along, they type in today equals date 11/13/2018. So they're creating a new date called today. Right? So today is a date object in the date class. Okay, and when you type that first line, it calls the init method, and the init method assigns 11, 13, and 2018 as attributes of the word today. So after this line is called, if I wanted to type today.month, it would tell me the month is 11. And then you call the next line, which creates a new object in the date class called WD, okay? And then we can call the method. Once we've defined this method within the date class, this diff method will tell us how many days there are between 11/13, 2018 and 11/12, 2013. Right? So diff just stands for number of days. And the order will matter. It would be really nice if we could just use subtraction. So this is a little bit complicated to type. Really, it'd be one of the things the user might want to do instead of typing today diff WD, wouldn't it be nice to type minus? So the minus operator, that little symbol, it's called an operator. That negative sign is an operator, okay? The minus operator is something you can define. You can say, I want the minus operator to implement the diff method. And that's something we'll talk about, right? How do we take one of the special characters on the keyboard, the minus, the plus, the equal sign, the ampersand, any of those can be redefined and associated with a custom defined method for your class. Okay? So for instance, you can define what you want the multiplication operator to be in the date class. You can say one date star another date. In other words, that multiplication will implement a particular method associated with the date class that somehow multiplies dates. And you define that to be whatever you want. Okay? And if you do this minus operation in some sensible way, maybe you'd get a negative sign if you reverse the order. Right? But that's going to depend on how you define the subtraction, the method that the subtraction operator calls. Okay. So for instance, on the bottom there, one of the things, once you implement this, you can ask ERA day stands for era day. What is the day in the current era? So the current era is AD, and you can say, how many days is it from today to the beginning of the current era? Well, the current era was the year one, day one, month one of the year one. And we could just use the diff operator to say, how many days has it been since the beginning of the era? And whatever day this slide was made, it was apparently 737,000 days into the current era. The DOW operator, DOW method, apologize, right? The way you call that is with the dot notation. And just here's some examples of it in use. If you type 10/28/1929 and ask for the day of the week for that, we'll call that method here. And the result will be just one particular day of the week, if that was a Monday, right? So there's some other examples down there at the bottom. There's a couple of ways to call a method using named objects or unnamed objects. So the difference between the stuff at the top of the screen and the stuff at the bottom of the screen is at the top of the screen, we name the object and call the method associated with it, right? So 10/28/1929, we've named SM1. And then we're calling the DOW method by using the dot notation referring to its name. You don't have to do that. You can skip a step. You can just, rather than calling 111 a particular name and then calling the DOW method on that name, you could just do it just straight from the constructor. So date 111 will automatically construct that 111 date object, and then you can immediately call the method on that date object. All right, so again, just to quickly review here, you use the class keyword to define your own class, okay? And then you use the init function That's the first thing you always do, is define the init functions as special functions. So you've got these underscores to say it's a special function. Every class has an init function, and that just tells Python how to create an object of that class. And again, it's what it does is it creates, it takes 3 numbers and the name of the object you're trying to create, right? So maybe little d was the example we had before. It takes the name of the object you're trying to create and 3 numbers, puts the name here, here, and here, and puts those 3 numbers here, here, and here. And now you're still, what you're doing there is setting those attributes, the month, day, and year attributes of that date object. I think this is all just reviewing everything we've said, just saying it again, okay? So again, this is somebody calling the date constructor to create a date object, little d, and then calling the isLeapYear method on that date object and getting an answer, which in this case is false, okay? Here's something we haven't seen yet is if you just type little d, that calls the Reaper function, the representation function. And that way that representation function was written, again, I didn't explain it because it used a lot of stuff you really don't need to know. But the way that representation function was written is it represents that particular date object by printing its month, day, and year with slashes in it as a string. Okay, and there it is in a little bit more detail there. Again, we talked about this earlier, but this is how you would write that. And again, I'm not going to go into that detail. It's just there. You can copy and paste that into your homework, and that automatically will format the date correctly as month slash day slash year. And you can see that, you can at least see the slashes there. Okay. What's going on in this slide? Let's see. All right, so we already talked about this stuff, right? We're creating a date object. We're printing that date object by calling the Reaper function. We're calling one of the methods, which is the isLeapYear method. Okay. And in the class definition, those objects that we've created are referred to as self within the definition of the class. All right, the double equal sign. Let's look at a particular example. So there's a problem associated with the double equal sign, which is that we don't know, Python doesn't really know what that double equal sign means when you start moving into a new class.
You got a minute?
Mark, turn your mic off. If WD is defined to be the date 11/12/2013, and WD2 is defined to be the date 11/12/13, we'd really like the answer to whether or not is WD equal WD2 to be true. But if you just type that, it will tell you that it's false. Okay? And again, the reason is the same reason we saw with lists last time, is that when you call WD, really what you're calling is a memory location where that object is stored. When you call WD2, you're calling a memory location where that object is stored. They're not the same memory location. So when Python compares those memory locations, it'll say, no, they're not the same. So they're not equal to each other, right? So that equal sign is by default just comparing memory locations, not comparing the attributes of those objects. We'd like that equal sign to be comparing attributes, you know, checking is the month the same, is the day the same, is the year the same. And if all those attributes are the same, then we'd like that double equal sign to return true. But you have to define that, right? So we have to define a method associated with the double equal sign. And then say, when the user uses the double equal sign, Python should call that method. Right? So we'll see how to do that in a minute. But that's all this slide is saying, is that when we call WD, what we're really calling is some memory location. I don't know, 1,274. Maybe that's a memory location. And 1011132. Right, there's a different memory location. And oh, sorry, I apologize. Now I'm seeing on the bottom. There's the memory location for the first object. Here's the memory location for the second object, and the double equal is comparing those memory locations. So by default, it will say not equals. All right. So we can write our own equality tester right here. So this is going to test are two dates equal. Right? Now, this is going to work exactly the way we said. We want to first check, are the years the same? If they are the same, then we check, are the months the same? If they are the same, we check, are the days the same? If all three are the same, that's when we're going to return true. If any of those conditions fail, then we're going to return false. So this is now a method. It's the equals method that we're adding to the date class. In other words, we're adding this extra bit of functionality to date objects. So now, if we go back to the previous slide, where we define WD and WD2, the way this is going to work is we can call the dot equals method. The dot equals method takes as its argument the self, right? So self is just going to refer to WD and takes a second date in parentheses. So you'd say WD dot equals WD2, and what you'll get there is either true or false, depending on this block of code, which compares the year, the month, and the day, right? That's not great. What we really wanted was to be able to execute this, right? So you got to define the method first, and then we got to say, hey, that double equal sign should call that method, right? So we've defined this dot equals method, and then later we'll see, well, how do we make the double equal sign call that method function, that equals function, okay? So again, this is now how it would work in practice, is you just type WD equals dot equals WD2. So WD references a particular date object. The dot says, hey, I'm going to call an attribute or a method of that object. Equals is the name of one of its methods. And that method not only takes itself, but it also takes a second date, which is here. Right? And the way that method works is by comparing the days, months, and years. And since they're all the same, it returns true. All right, now what you see here is almost the exact same thing, right? It's almost the exact same thing. It's the same Booleans. We're comparing the year, we're comparing the month, we're comparing the day. But instead of calling this method equals, it's written in a funny way. It's got a double underscore, EQ, and a double underscore. Double underscore EQ, double underscore, is a very, very special method that will get called whenever somebody uses the double equal sign. Right? So if you want to redefine the functionality of the double equal sign, you define your own underscore EQ underscore method. Right? So underscore EQ underscore is a special name that's always associated to the double equal sign. And if you define your own custom method and you call it underscore EQ underscore, it adds that new functionality to the double equal sign, okay? There's a term here that's not on any of these slides. The term is called overloading, okay? Overloading means we have some symbol, literally a key on the keyboard or a set of keys on the keyboard, right? In this case, it's the double equal sign. The double equal sign is an overloaded operator. And all that means is that the double equal sign represents different methods for different classes. So you can define the double equal sign to be something for the date class. Someone else defined the double equal sign to be something for the integer class. Someone else defined the double equal sign to be something for the string class, comparing if two strings are equal. Okay? So the double equal sign is called an overloaded operator. Overloaded just means it has different meanings in different contexts. It's just like the English language where there's certain words that have different meanings depending on the context. Okay? So the way you define your own overloaded operator is with one of these double underscore methods. And there's quite a bit of them. Here's an example of a few. There's probably about 50, I would say. And if you just Google Python overload or overloaded operators or Python class overloading, anything like that, there's zillions of websites where you'll just get a list of all of these. There's literally, I'd say that there's 50 to 100 of these. Okay? So the one we just saw is the double underscore equal double underscore. That always takes itself, the self again represents the object that you're going to use to call the double equal method. And it takes a second object. And what it's going to do, presumably, is if you define the method correctly, it will compare the two. You can define that method to be what you want. You can define double underscore equal double underscore to be something that somehow adds two dates if you want. And then whenever somebody used the two equal signs, that will just represent addition. But I mean, you wouldn't want to do that, but you could, right? What this special symbol is doing is it's letting you redefine the double equal sign however you want, okay? Same thing with not equals. That's just the NE method. Less than, the less than symbol, you can redefine by the LT method, okay? And it just keeps going like that. If you want to redefine what the plus symbol means, then you can use the underscore add underscore method, right? So again, I mean, a perfect example of this is when you use that plus sign with strings, it does something, right? It takes two strings and it concatenates them. If you use the plus sign with two integers, it actually adds them. If you do it with two lists, it creates a bigger list. If you do it with two complex numbers, it adds the real parts and adds the imaginary parts, right? Those are all different classes: strings, lists, integers, real numbers, complex numbers. Those are all classes within Python. And for each of those classes, they defined this underscore add underscore method, which gives the overloaded operator plus different functionality depending on which of those classes you're using. Okay? If you want to know what all of the methods are associated to a particular class, that's when you use this dir. The dir command, if I type dir of 7, I'll get all of the methods, all of the functionality that has been programmed into Python associated to the class that 7 is a part of, which is the integer class. So dir of 7 will tell me what all of the methods are for the integer class. All right, here's more. Right, so we've got add, subtract, multiply. That'll redefine the plus sign, the minus sign, the multiplication sign. I add, right, increment add is another one we've seen. Plus equals is supposed to increment whatever the existing thing is, right? So for example, you're going to define a tomorrow function when you create your date class for your homework. You can use the plus equal sign there by defining the iadd method. Instead of calling it the tomorrow method, you could call it the iadd method, and then plus equals will work on your date, right? And that makes sense. If you have a particular date and then you say, you know, d plus equals 5, then that should change the value of your date by advancing it 5 days into the future. Okay, you can define that however you want. Let's talk a little bit about how this day of the week function is going to work. So the day of the week function, um, you've got, sorry, I don't know why this slide is here. I apologize. I think you're going to do this yourself. You're going to figure out how the day of the week function works. So let's just move on here. Let's talk about the is before method. The is before method is going to take two dates. So it'll take the date you're going to use to call this method and a second date, right? So again, if WD is a date and WD2 is another date, you could type WD dot is before, which calls a method, and then put in parentheses WD2, a second date, and then that'll call this method. And in the definition of this method, self will be WT, right? So if you write, let me write this out. If you write in the command line WD dot is before WD2, if the user calls that, then this becomes self, and this will become D2. This becomes self, and this becomes D2. Right? So whenever you see self.year, that's going to represent WD.year. And D2 is going to represent WD2. Right? So if you call WD.isBefore WD2, then when this method executes, this will be WD, this will be WD2. Right? So what this code is doing is it's checking, is the year for WT less than the year for WD2? If it is, it'll just stop and return true. Yes, WD is before WD2. If it's not, it'll compare their months. If those are not, it'll compare their days. Right? So then you can call this kind of functionality. So when you call this line at the bottom of the screen here, this date becomes self, and this date will become D2, and then it'll go back up and do all those comparisons at the top. I don't know why this is here. Let's just move on. Sorry. Now, rather than, once you've defined that is before function, you may want to say, hey, that's great. I like users to be able to call is before because it's very descriptive. But, after a while, it's going to get to be a pain in the ass typing out the word is before. So let's also not only define this is before method, but let's also endow the less than sign with the exact same functionality as the is before method. And the way you do that is with this underscore LT underscore, right? LT stands for less than. And the way the less than method, the way the LT method is going to work is it's just going to call the is before method. So this assumes you've already defined the is before method. We're going to now overload the less than symbol by just creating the underscore LT underscore method that calls the is before method. That's all this is doing here. Here's a shorter way to do that is you just return the result of is before. So the longer way to do it is you say, well, if self is before D2, then return true. If self is not before D2, then return false. And that's kind of too much work because self is before D2 already returns true or false. So you might as well just return the result of self is before D2. I'm not sure why those two slides were here. I would have just jumped straight to this one. The point is that the less than symbol on the keyboard, we're going to now just redefine to be the result of self is before D2. You could do the same thing with The greater than symbol, all you have to do is swap the order, right? So if I want to know, is W after W2, if sorry, D is after D2, if some date is after D2, well, I could just check, is D2 before D, right? So the way you'd write that in code is I'd put D2 here and then self here. So compare that line to the line up there, right? It's a lot like saying, once I know how to check if 2 is less than 5, I can check if 2 is greater than 5 by checking if 5 is less than 2, right? So once I understand the less than symbol, I could just swap the inputs, and that gives me a way to define the greater than symbol. What are we doing on time? We got 2 minutes. Okay. Where am I at? All right. Let me just check where I'm at here. All right, I think we're almost done. Again, the representation function is going to print out something. The tomorrow function will advance the day of the week, so the date by 1 day. And if you want, you can now redefine plus equals to implement the tomorrow method. Once you've defined the tomorrow method, you can then go a little further and overload plus equals so that it calls that tomorrow method that you've defined. Same thing with yesterday. You can define a yesterday method and then overload the minus equal operator so that it just calls the yesterday method. Now, let's just talk about the tomorrow method real quick. We only have a couple minutes to do this. I'm going to go overtime a few minutes. Apologize for that. If I want the tomorrow method, then again, I've got, normally what I would do is I would just add 1 to the day. But I may now exceed the number of days in that particular month. So for example, if it's January 31st and I add 1 to the day, now I have, looks like I'm at January 32nd, but 32 is bigger than the number of days in January. So we've seen this before. We saw this when we did, we were generating random birthdays when we were doing the Monte Carlo methods. We had this DIM list, stands for days in month. This was supposed to be the number of days in each month of the year. We had 0 because there is no month 0, right? So these were tied to the index. This is index 0, index 1, index 2, right? So the index corresponds to a particular month. So month 1 is January, and that's 31 days in January. Month 2 is February. Most Februarys, there's 28 days. We'll talk about that in a minute, etc. Right? So with the 0 at the beginning, don't let that throw you off because there is no month 0. So what we really want to do is we want to check, well, once we've advanced things by 1 day, is self.day at this point greater than the number of days in that month? Okay, so we're going to look at the number of days in the month corresponding to self.month. Okay, so again, self.month refers to what month it is for that particular date. And then when we look that up in the DIM list, that'll tell us what month it is. So again, if D starts out as being 1/1, whatever, 2020, sorry, 1/31, 2020, then the month is 1. So DIM of 1 refers to 31. Okay, so if I advance the day here by 1, now the day is 32, so this will be 32, and 32 is bigger than the number of days in January. In that case, now we want to reset the day back to 1, right? Because now it'll be the first day of February. And we want to advance the month by 1. Sorry, that was a plus equals 1. Advance the month by 1. But we may now have advanced the month to the 13th month of the year. So now we've got to check, is self.month greater than 12 once we've advanced the month? And if it is, now we want to reset self.month back to 1 and advance the year by 1. Okay, so that's code you're going to write. Well, that's code right here. Right, so there it is. So that's exactly what I wrote out up here. Is what I wrote out a minute ago. This is what I talked to if the month has gone past 12. There's something a little bit fancier on this slide. Is instead of a 28 here in the second month, we have a variable called F days, which are February days. So you may want to define your own function before this, which tells you how many days there are in February, depending on the value of self.year, right? So self.year will tell you how many days there are in February, and that's going to depend on the is leap year function. So this is all coming back to itself, right? So you'll call to figure out how many days there are in February, we're going to call the is leap year function. If it's a leap year, then there'll be 28 days. If it's not a leap year, sorry, there'll be 29 days if it's a leap year. If it's not a leap year, then there'll be 28 days. So one of those two values will be set to the value of F days, February days, okay, depending on the value of the is leap year function. And then we can execute this code, which will advance the day by 1 day of the week, right? So it's nice how all these methods can build on each other. It can be nice and confusing. So this is how this is a little bit fancier way to do that. You can just add the value of is leap year, and again, now this depends on functionality built in some other classes. So 28 is referred to, 28 is referred to as an integer, right? The name 28 is an integer object. Somebody's defined the plus operator so that when you add a Boolean to it, we've seen this before, if the value of that Boolean is true, then 28 plus true will return 29, and 28 plus false will just return 28. So this will do the same thing as the previous slide, where it advances, the value of F days will be 29 if it's a leap year, and will be 28 if it's not. So it's just a quicker, kind of slicker way to set the value of F days. Yesterday is very similar, right? Do the same thing here, define the number of days in February, the number of days in the month, but now we want to decrease the day and check, did the day go back before 1, right? We don't have a day 0 in any month, so we have to check, is the day ever less than 1 if we decrease the day, and if it is, we have to decrease the month. But if that sets us back, then we have to go to the previous month, to the last day of the previous month. So that's what this is right here, is it's referencing the last day of the previous month. And you just kind of think through the rest of it there. That's our last slide. So you're gonna, again, have some time to really think about this in your homework. I got really confused in the day of the week last time. It's Thursday now, so we can talk about this lab on Monday afternoon, or in my office hours Monday morning, and then this will be due Tuesday at 8 a.m. So you have a lot of time now to think about this. Again, if it's the first time you've ever seen classes or objects or methods, there's a lot of terminology here. Just take it slow, rewatch this video if you have to, and go ahead and work through your homework slowly. And it also helps to do some Google searching. There's a lot of stuff on the internet about methods and objects and classes and overloading and attributes. So there's lots of stuff out there. The more you do it, the more it'll become second nature. And again, all this new language we're throwing at you today is it's just language, and language is something that as you use it, you get used to it and it becomes second nature. All right, so I hope that was somewhat understandable. I'm sorry for going over time, but are there any quick questions before we move on? There is a question I see on the chat that says, can you please open the late submission on Gradescope for the assignment that was due this morning? And I'm sorry that I have not done that, but if you want to submit your homework late, you can just email it to me. I think that's easier than changing the Gradescope settings. So just email it to me if you want to submit your last homework assignment late. It's fine. I'll certainly accept that. Any other quick questions, either through the chat or somebody wants to just turn on their mic? All right, great. I'm going to end class there. And I will see you all next week, if not sooner. Bye.
Thank you.